All right. Okay, here we go. This is a video of me explaining the interactions and residualized effects. So we have, I just need to make sure that everything is functioning. Yeah, looks good. Yeah, okay, good. I have my data, the same data that you saw in the notes. This is for week 13 notes. So I have alcohol at 0 or 1, antabuse at 0, 1 alternating, and these are the responses. These are the mean effects or main effects of alcohol. And you'll notice that all 12 subjects get the same effect as their group classification. So in terms of alcohol, the zeros get the same mean effect and the ones get the same mean effect. So you can see here there's a difference of about almost 10 between the two groups for alcohol. Similarly, for antabuse, there's approximately a 10-point difference. It's 9.83, but we'll call it 10 for good measure for rounding. And so these are main effects for alcohol and for antabuse. And the Y observed that we would see here is nothing more, or the Y, sorry. This are, I'm messing it up already. Okay, so this is just the predicted value that we're getting with respect to our expected effect. Okay, and you can see here it's F2 is Y predicted. And the Y predicted is nothing more than the average for the cells. That's what we're seeing here. But then the cell means can be further divided into two different effects, the alcohol and the antabuse. So while those are individual cells, we're getting kind of the compared effects that we're expecting. And as a result of that, you're going to see here, so you can see in the Excel or Google Sheets method, you can see here that I take this effect, and this is the average between the 0 zeros, 1, 2, and 1. So if I take 4 and I divide it by 3, because there's 3 people in that group, you get 1.333. Similarly, because this is the average of all of the 0 1s, it's 4, 5, and 6. That's 15. 15 divided by 3 is 5. And then we come to the 1, 0. It's 4, 5, and 6. Just so happens to be 5 is the average. So 5, 5, 5. And then 20, 21, and 22. That averages out to 21. Okay. So those are all of those values that we would expect, or these are the observed cell values. Okay. The mean, or Y bar observed. And then we want to get residualized effects. Now, how do we get residualized effects? Well, we take the observed and we subtract out the main effects. So I've got a main effect for alcohol and a main effect of antabuse. So if I take 1.33 and I subtract in parentheses this main effect and this main effect, I get a residualized effect, after the interactions, or after the main effects. And so therefore I get a -5. That's the residual after the main effects. And that's what I was saying is actually computed. Now, what I wasn't clear about is if you just take all of these and you take a mean effect for these, for all of these residuals, and you simply calculate the difference, which is the G2 or G2 here, which is this residual, subtracting out the average. So we're centering, we're scaling these so they're centered. By scaling them so they're centered, it gives us centered values. So this value is nothing more than -5 minus an 8.08. So if we subtract a negative, it becomes addition. So therefore, when we just flip it around, if you have 8 and you take away 5, what you're going to get is 3.08. Similarly, you get minus 3.08 when you take minus 11.17 and you minus a minus 8.08, you get a minus 3.08. And if you just turn these all into positives, you know that 8.08 plus 3.08, these are all rounded. If you want to know what the actual values are, what I can do is I can just simply expand the number of significant digits. And you'll see that the significant digits are indeed what I've said they are. But we're just making it simple. So I think that you should see that all I'm doing here is I'm centering these values. By centering them, they give me an idea about what the effect is centered. That's what I was trying to explain. But that's less important than the big picture. And that's all I wanted to talk about. All right, I will upload this video as soon as humanly possible.